Hey, welcome to The Explainer. Today we're going to tackle something we do every single day without even thinking about it, telling time. It seems super basic, right? But the rules and the logic behind it, they have some really interesting quirks. So we're going to break it all down, how to read a clock, navigate a calendar, and clear up some of those classic points of confusion.
All right, let's kick things off with a real head-scratcher, one that honestly trips a lot of people up. Why is it that 12 a.m. is the very start of a new day, but 12 p.m. is smack dab in the middle of it? It seems kind of weird, but if you can wrap your head around this one, you've pretty much cracked the code for the entire day.
Okay, first things first. Let's talk about the classic analog clock. The one with the hands. It's not just about reading numbers. There's actually a more descriptive, almost story-like way to tell the time. It's all about the minute hand's journey around the dial.
So you could just say the time the digital way, right? 9:50. Super direct, totally precise. But then there's the analog way. 10 to 10. And that's not just some old-fashioned thing to say, it's a completely different way of thinking about it. You're not just saying what time it is, you're describing where the minute hand is in relation to the next hour. Kinda cool, huh?
So here's the trick. Just imagine splitting the clock face right down the middle, from the 12 to the 6. If the minute hand is on the right side, you're counting how many minutes have gone past the hour. But the second it crosses over to the left side, your whole perspective flips. Now you're counting the minutes you have left to get to the next hour. And on this journey, there are a couple of key landmarks. The first one is when the minute hand hits the 3. At that point, it's gone 15 minutes, which, if you think about it, is exactly 1/4 of its 60-minute trip. And that, right there, is where we get quarter past. All right, the next big stop on our clock face tour is the 6. This marks half past the hour. It's the literal halfway point, and it's also the pivot. This is the moment our language totally shifts from talking about what's past the hour to what's coming to the next one.
Okay, so we've got the 60-minute hour figured out. Now let's zoom out and look at the bigger picture, the two 12-hour chunks that organize our entire day. This is where AM and PM come into play, and they're absolutely crucial.
So a brand new day officially kicks off at 12 midnight. That whole block of time, all the way until noon, is called AM. It actually stands for a Latin phrase, ante meridiem, which just means before midday. Makes sense, right? Then, from 12 noon all the way to the next midnight, you're in PM territory for post-meridium, or after midday.
All right, here's a classic little time puzzle for you, and it plays right on these boundaries we just talked about. Let's say it's 1 a.m. What time was it exactly 1 hour before that? Now, your gut might immediately say 12 a.m., but hold on. Crossing that midnight line is where it gets a little tricky.
You gotta remember, 1 a.m. isn't just an hour. It's the first hour of a whole new day. So if you rewind the clock by 1 hour from there, you land at the exact moment the previous day ended, 12 o'clock midnight. It's like the final period at the end of yesterday's sentence.
Okay, so calculating how much time has passed between 2 points, especially when you have to cross that AM to PM divide, it can feel like a really clunky math problem, can it? But good news, there's a much more intuitive way to do it that lets you skip all that complicated subtraction.
The whole trick is to stop thinking about subtraction and start thinking in jumps. It's a simple 3-step process. First, you make a tiny jump to get to the next clean hour. Then you make the big jump, covering all the full hours. And finally, you just add on the little leftover minutes at the end. Easy. All right, let's put this into practice. Imagine a movie starts at 10:45 in the morning and ends at 2:05 in the afternoon. How long was it? Let's use our jumping method to figure it out. Okay, step 1, our first jump. We're at 10:45 a.m. We just need a quick 15-minute hop to get us to a nice, round 11 a.m. So let's bank those 15 minutes and move on. All right, now for the big leap. We're at 11 a.m. We can easily jump forward by the full hours. So 11 to 12, that's 1. 12 to 1, that's 2. 1 to 2, that's 3. So a 3-hour jump gets us all the way to 2 p.m. And here's the last little bit. We're at 2 p.m., but the movie ends at 2:05, so we just need to add that final 5-minute jump to get to our destination. So now, all we have to do is add up our jumps. We had 15 minutes at the start, then that big 3-hour jump, and then 5 minutes at the end. Put it all together, and what do you get? 3 hours and 20 minutes. See? No complicated math, just a simple, logical path to the right answer. So this whole AM-PM system is what most of us use every day. But let's be honest, using the same number for two different times of day can sometimes be confusing. And that's exactly why another system was created, one designed to get rid of that confusion for good, the 24-hour clock.
You've probably heard it called military time, and you see it a lot in transportation and logistics, and for a really good reason. It gives every single hour of the day its own unique number, from 00 all the way up to 23. So 9 a.m. is just 0900 hours, but 3 p.m. becomes 1500 hours. There's just no way to mix them up.
And converting is super simple. For any AM time, the hour number stays the same. For any PM time after 12, you just add 12. That's it. It's a really elegant solution to that whole morning versus evening problem.
Now, this kind of logical, step-by-step thinking isn't just for hours and minutes. We can actually scale it up and use the same kind of principle when we're counting days over a longer period, like for a vacation or a project deadline.
Okay, so when you're counting a span of days, there's one golden rule you have to remember. You have to include the start date. If something runs from one date to another, both of those days are part of the count. It's a small detail, but it changes the math.
Let's make this real. Say your vacation is from May 15th to June 28th. To count the days in May, you don't just subtract 15 from 31. Remember, you have to include the 15th. So you subtract one less. You subtract 14. That gives you 17 days in May. Then you just add the 28 days in June, and your total vacation is 45 days long.
So there you have it. We've decoded the language of the clock, figured out the structure of our day, and even tackled calculating duration. But all of these are just systems, right? They're frameworks we invented to make sense of something we can't even touch. And that leaves me with one final thought. We've gotten so good at measuring time, but does mastering the systems we use to track it actually change how we experience it? Something to think about.